All right, for question 17, we have a cyclist going from A to B, and there are three segments of this travel. The first one is they start at rest and they're accelerating the whole time. So at this point, the acceleration is 0.5, they go a distance of 36 meters, and then they travel at a constant speed for 25 seconds. So we get somewhere. Then for the second stage, they're at a constant velocity, constant speed, and it's 25 seconds. And then we get to the third stage, and they slow down with a constant deceleration. All right, they're the three stages. All right, we know the total distance is 210 meters, which may be helpful at some point. We know the constant speed is for 25 seconds, so the time here is 25 seconds. We don't know what the speed is at that point. We know that the first section, the acceleration, is 0.5 meters second squared, and we know that the distance, let's go displacement, is 36. Okay, so we're good. So to do this question, we're just going to break it down into one stage following the next stage, and we should be right. Okay, for stage one, we want the total time. So for stage one, we want the time, and we know the initial velocity is 0 because it started at rest. So which formula does displacement, initial velocity, acceleration, and time? Okay, we are after time. So we know that it traveled 36 meters. The initial velocity is 0, that's helpful. Half of the acceleration is a half of a half, that turns into a quarter, and we'll multiply by time, that's meant to be squared, right? AT squared. This looks very handy. We get t squared equals 4 times 36. So t is equal to the square root of 1.4. In other words, my time in stage 1 is 12 seconds. That's great. Stage 2, the time is 25 seconds. And stage 3, we don't know a lot. We know the final velocity is 0. We need to know more things. So we need to know the velocity in stage 2, which is going to be the velocity at the end of stage 1. So we want to find the velocity at the end of stage 1. We should be able to do that fairly easily. Velocity is u plus at. And so in this case, our final velocity is going to be 0 plus the acceleration, 0.5 times 12, which is just a half of 12, which is 6 meters per second. Right, so now we know in stage 2 that the velocity is 6 meters per second. And the time is 25, which would allow us to work out the distance if we want to work it out, actually. That would be helpful. So let's work it out. Velocity is distance on time. So the distance is velocity times time. We've got 25 seconds multiplied by 6, and that would be 150 meters. Now we have the distance for the second stage. All right, coming into the third stage, we now know a lot more. We know that the initial velocity is what we're exiting the second stage at, which is 6 meters per second. We know that the final velocity is 0 because it comes to a stop. And we should be able to work out the distance because it's a total of 210. And we have traveled 36 plus 150. 36 plus 150 is 186. And so 210 minus 186 is 24 meters. All right, and what are we trying to find on the, we're trying to find the time, aren't we, on the final stage? What is the time to decelerate back to 0? which formula uses S, U, V, and T. That's S is equal to half of initial velocity plus the final velocity multiplied by the time. So we get 24. This is equal to a half of 6 plus 0 multiplied by the time. Half of 6 is 3, and 24 divided by 3 is 8. So our time here is 8 seconds. Okay, that allows us to find the total time. The total time, after analyzing every section, is going to be the time in the first section, which is 12, plus the time in the second section is 25, plus the time in the third one is 8. And that equals 45 seconds. All right, for part 2, we have a car that starts 24 seconds after the bike and goes in the same direction, constant acceleration, catches the bike, and we need to find the time to catch the bike from when the cycle starts. Right. It'll be a lot easier to do a comparison if we work with the time from where the car starts, and then we can add on the 24 seconds because it takes 24 seconds after the bike starts, the car starts. It's confusing, right? All right, we need to find out where the cyclist is at 24 seconds. It takes 12 seconds to accelerate, which means it's 12 seconds into the second stage. And so its displacement, let's go at 24 seconds. The bike's displacement is going to equal the 36 meters it went in the first stage, and then velocity is distance on time. Distance is velocity times time, plus the velocity, which is 6 multiplied by 12, because it travels another 12 seconds in the second stage, 12 seconds in the first stage. And so 36 plus 6 times 12 is 108 meters. All right. So the cyclist is 108 meters with a head start on the car. So if we wanted to now work out, let's make time equals 0 at this point. The position of the cyclist will be, or the displacement is going to be 108 plus the velocity times time. And that's going to be 6 times whatever the time is. So we have a position based on time for the cyclist. Now all we need is a position based on time for the car. Okay, so for the car, we're going to use displacement is ut plus a half at squared because the car starts at rest, so ut is 0, and all we have to deal with is a half of at squared, which is, it's got an acceleration of 4 meters per second. Half of 4 is 2, so we get 2t squared. All right, so that's the displacement of the car, the displacement of cyclists. When they equal each other, we have the time that they caught from when the car started. So let's work this one out. We'll get 2t squared is equal to 108 plus 6t. All right, we can rearrange that into 2t squared minus 6t minus 108 equals 0. Divide everything by 2, we'll get t squared minus 3t minus 54 equals 0. What multiplies negative 54 adds to negative 3 minus 9 and plus 6. Therefore, the time is 9 or time is negative 6. All right, we can throw away the negative time and say it's 9 seconds after the car leaves that the car catches the cyclist. And so the time to catch is going to be the 24 seconds head start plus 9. Which is 33. Done.